Welcome all. Today we will see something about LR parsing, where we will see LR parsing table construction as well as LR parsing algorithm. So it is very simple, where you will see how this parsing table is constructed. So let me write something about the table construction, right? So we are discussing something about LR0 parsing table construction. There are some difference between other parsing table, means other LR parsing, I should say LR1 means SLR or CLR, LALR. There will be a little difference in the parsing table construction of those LR parsers. Here this is simple LR0 parsing table construction. So although the method will remain same, the only difference will be where particular reduce entries are being done. So let us start with this thing. They are just very simple 4 steps. What you are going to do is, first thing, you will just take the augmented grammar. We have already seen what augmented grammar is and what are LR0 items in the last video. We have also seen what are closure functions and goto function in the last video. So here we are taking what is the augmented grammar. Basically what happened in augmented grammar, that we are just adding one extra production there, which is we are calling as augmented production, right? Just one starting, as your starting symbol was S derives something, so we are just adding one production S dash which derives S. That is the only thing, and you will now understand while table construction why it was important. So now in the second step, what you will do, you will find the closure of this augmented production. Okay, find the closure of augmented production, right? So in your augmented grammar, you have one extra production, you are calling it as augmented grammar. So sorry, augmented production. So you will take that augmented production, which is extra production, which will derive your starting symbol, right? So you will take that production and find the closure of it, right? Now what you are going to do, this is something where you will use this second step, and using this second step, using your step 2, you will get all the LR0 items. You will get all the LR0 items, and for this you can use the help of DFA, right? Okay, with help of DFA. So you will create a DFA here. Now what you are going to do, if at all in some cases some extra states can be there in your DFA, you will try to reduce your DFA. And after that, what you will do in the fourth step, you will create a parsing table from the DFA. I should say you will convert your DFA into parsing table, or you can also say reduce your parsing table, reduce the DFA into your LR0 parsing table. So now these are the 4 simple steps where you will take your augmented grammar, you will find the closure of augmented production, and then you will keep on finding you will create a DFA and keep on finding these LR0 items using the closure of this new items. And after that, once you have the full DFA created, you will then reduce it to the LR0 parsing table. Now the question is, can we have some example, and can we have DFA created, and if we are able to create a DFA for some grammar and then convert it to a particular parsing table, it will help us understanding this thing, right? So let us take one example. Example is simple grammar. Let us take the same thing. It was G gives AA, as well as this A gives AA as well as B, right? This was our grammar. So can we have the augmented grammar? Augmented grammar will be just one extra production, and the place of S, let me keep it as S. This is G. Okay. So we will have one extra production, which is S dash gives S, right? And the other 2 productions are S derives AA as well as A derives AA, and one more production, A derives B. So now this is our augmented grammar. So using this augmented grammar, if you remember this 4 steps, one is take the augmented grammar, take N, right? Then find the closure of the augmented production. Augmented production is this one, right? So we will consider the closure of this. Let us assume we have one state in our DFA, and the augmented production is S dash derives S. Now what in a step 2 it is saying, we have to find the closure of this augmented production. Closure of this augmented production, I should say it is having dot here, right? So closure of this will be, you just find out the first of S, right? First of S is, okay, do you remember how to find this closure of S? Whatever is after the dot, right, you just want to keep that production here. Okay, so you will keep the S gives dot AA, no issues, and for every newly added production you will do the same, right? So you have just added this production, you have seen the dot here, dot is A, so you will find A is a non-terminal, so for this A you will again find some production if at all they are available. Yeah, they are available. You will keep these 2 productions as well, right? A derives AA and A derives B as well, and for this you will have dots. Okay, very simple. Now these are terminals, so they are not going to derive anything, so it is okay. So let me name it as state 1, right? Okay, I0. Now here, now what we are going to do is, there are 4 dots I can see for S, for A, for this small a and small b. So what I can understand in this DFA, that there are 4 possibilities, right? a symbol S can come, a symbol A can come, a symbol a small a can be encountered, a small b can be encountered, right? So we will have four transitions from this state. So let us assume what happens with when A comes. In the last we will see what happens if S comes. Okay, let me start with what happens with S comes. If at all we have a S, right, symbol S is coming. In that case we understand that now everything has been completed. So if something S is coming, so what happens? We will move the dot after S, right? This is what we do. And now after this dot there is nothing, so we are not going to find we are not going to add any other production, right? So this is something what will happen. Very simple. Now if at all A is coming, right, for this production, so what will happen? We will go to a state where you will have the production S derives A dot A. A is coming, right? And after dot we have something. This is also A. So for this, whatever the productions are there here in the grammar, we keep those productions. What are them? A derives AA as well as B, a dot also. Okay, let me name it as it was I0, it is I1, this is I2, and later on we will have I3. Okay, I3, let us have when A is coming, right? When A is coming, a small a, in that case another state, let me name it I3. So here what will happen? A, this dot will move one step, one symbol after this A, right? So what will happen? A derives A dot A. Now this A is again coming, so for this A we will have the other productions. A derives dot AA as well as dot B, right? No other productions are going to add, right? Okay, so it's okay. What happens if B comes? In case B comes, what will happen? We will have A derives B dot, right? Dot goes after B. So no other production is going to be added. Let me name it I4. No issues. Now for these states again we have to examine what are the I should say possible new inputs on which they can react, right? So for this state we already know it has already reduced, right? So no other productions. Now here in this case we have three options. A can come, another symbol small a and a small b can come, right? So now let us see what happens if capital A comes. If capital A comes, so this is, production will be reduced, right? So let us go to a new state with A is coming. We are going to a new state. We are naming it S derives AA dot, right? Let me name it I5. Now since it is reduced, no other production is being added. Here A can come. In this production we already know what happens if A comes and what happens if B comes, right? If in such cases when A comes or B comes, we are going to this and this state, right? So if A is coming, what will happen? A will move further. You can have an extra state, no issues, but you can always use this state, right? A derives A dot A. So next is the other production. So I think this is the best way. Here you will, if A is coming, you will come here, right? Now what happens if B comes? Definitely you will go here, right? Let me draw it like this. If B comes, you will come here. No issues. Now in this case, after this, here also what can happen, this A can come, and here again a small a or a small b can come, right? So here again same production it is. So if at all this small b can come, so in that case now what can happen is for A we can go, so for considering this production, if A comes, is there any state like that? It was A capital, right? So no other state. So let us assume this is what happens for this production. If A comes, we will go to a state which is A derives A dot, and since it is reducing, so no other production, let me name it as I6. And for this production, if A comes, what will we do? We will come to this state only, right? And if B comes, we will go to this state, right? Now any other thing? Okay, this has been done. Here no new productions are there, nothing to reduce. Here this is already reduced, this is already reduced. So all of this is the final DFA that you are getting, right? In this DFA creation process, if you make some mistake, you will get extra states, but those states will have same information, right? Here in case for A you are coming to this state, right? In place of having this state, if you will create a new state with the same information, you will create extra information, right? So if you mistakenly do that kind of thing, you should reduce those states, right? So let us assume this is the final DFA we are having. So using this DFA, the fourth step was to reduce this DFA into a LR parsing table. So now what this parsing table will look like? In this parsing table, actually you will have I should say your states here, right? I0 to I5, let me say as 0, 1, 2, 3, 4, 5 and 6. Here what happens, there are two parts actually for the terminals and non-terminals. So for terminals we have action, and for non-terminals we have go to. Okay, action can be shift or reduce, and you already know go to function. So go to will tell you on which state you have to go, right? Go to. So for terminals, I think we have two terminals A and B, and one terminal is dollar, right? Int symbol. So for A you will have an entry, for B you will have an entry, and for dollar you will have an entry. Other thing is go to. Two symbols I can see, one is S and another is A, right? So for S you will have an entry, for A you will have an entry. So now let us create this thing, A as well as B. So now it is very simple to keep here what happens in state 0. In state 0, what happens if A comes? A small a comes. So what you do? You go to state 3. Simple. So it is shift state 3. In case of if you get a B, you go to state 4, right? So shift state 4. No problem. What happens if dollar comes? Okay, so nothing given, right? Okay, let be. Here there are possibility of coming S, capital A and capital B, sorry, capital A. So this entry will also be made, but since it is a non-terminal, the entry will be made here, right? So if capital S comes, we have to go in state here 1. You will just mention the state number. Now if you get capital A, in that case it is state 2. Very simple, right? Similarly, let us do these things for all the states. Here in this case it is state 1. Since this final, I should say the start symbol is reducing here, so if at all this is the case, the start symbol is reducing, then this thing, we can say that the string was accepted. So only one possibility is, if at all dollar is coming, then it is, we can say it has been accepted. No other entries are here, no problem. For 2, what is that? The possibility of getting capital A, small a and small b, right? So state 2, a small a is coming, we are going to a state 3, shift 3. If small b is coming, we are going to a state 4, so shift 4. In case capital A is coming, what we are going to do? We will go to a state, capital A means state 5, right? So state 5. Now in state 3, this is the state 3. If A comes, we will keep on coming here only, so shift 3. If B comes, we will go to state 4, so shift into 4. And what happens if other thing is A? If A comes, we will go to state 6, right? So let us keep it as 6. Now in case in state 4, where it is here, in state 4, what happens if A comes? Nothing, right? What happens if B comes? Okay, if dollar comes. So somehow you can understand that here this thing is being reduced. So since it is this production is reducing in this I4, so what will happen now? It is actually reducing, right? So let us have one understanding that what is being reduced, right? Let me say this is being numbered as 1, 2, 3. In that case, what will happen? Suppose here in this production I am naming it as 1, this as 2 and this as 3, right? So what is happening? We have just to make that this is a reduced entry for this particular production. So it will be a reducing the third production, and actually this information is kept in all the this columns of terminals, right? Reduce R3. Now fifth, state 5 is here. Here we are also reducing something. So this is a production which is being reduced. S derives AA. This is being reduced, so this is number 1. So let me write it R1, R1, R1. Reduce 1, reduce 1, reduce 1. In 6, what is happening? A derives AA, this one, right? So we have numbered it 2. So we are keeping here R2, R2 and reduce 2. Okay. So this is how you make a parsing table construction for LR parsers. So now the next thing that you have to see is the algorithm, right? LR parsing algorithm that will help you in parsing a given a string with the help of this particular table. You will reduce something, you will shift something, right? So you also understand that when we parse a string, you have to interact with this table as well as the input string and one given stack. So let me write the LR0, I should say LR parsing algorithm. This parsing algorithm will be same for all the LR parsers. LR parsing algorithm. Actually, as I told that only the table construction will change, and I will tell you that only the reduce entry changes. That in simple this LR0, we are keeping this thing in all. We are keeping the reduce entry in all the columns. You will see in SLR that only at particular places we are keeping this information. Maybe in just the follow of particular non-terminal. Or here what we can do is we can also keep it in look ahead symbols. We will see these things as we will see next. So basically here we will see 4 variants are there: LR0, SLR, CLR and LALR. And for all of them this LR parsing algorithm will be same. This table may vary a little bit, right? And this DFA construction may also vary a little bit for some of the parsers. So what happens in this LR parsing algorithm? Actually, suppose you will always be in one of the state. So suppose S is the state, where this state is on the top of a stack, right? So initially when you will enter, you will have a particular state in the stack. So it will always be maybe 0, but somehow you will have a state. So assume let S is, let S be the state on the top of the stack. At the same time, let A be the look ahead symbol. A be the look ahead symbol. Okay. So there are 3 things that you see. The first thing is, suppose this entry in this particular table, you will see the entry in the particular table for given state and combination of this string, right? So 0 A, what you are going to do, right? So that is very simple thing that you will see. So you can write it like if action, I should say like this, S comma A is equal to some shift entry like SI. If it is a reduced entry, we will see in the second line what we are going to do. If it is a shift entry SI, then what we are going to do? Then we will just shift A, the symbol A, and particular I, and increment the pointer. Which pointer? Input pointer, right? Now the second case, if this particular entry is a reduced entry, in that case, if action SA is a reduced entry, let us say RJ, right? In that case, what we are going to do is we will do these things. Suppose this reduced entry is particular, I should say production, right? As we have learnt, this R1 means we are reducing this particular production. So it is always the production, right? So if this production is something like, suppose if this Rj is something like alpha derives beta, in that case what you have to pop from the stack is 2 times this beta symbol. You will pop these and then replace with this alpha, and replace by alpha. No problem. Okay. Now one more thing. Now you have just kept the alpha in this particular stack. There will be something below this alpha, right? And usually you will see it will be a symbol. So if that particular something, suppose S, I should say M-1 is a state below alpha. In that case, you will have to push. What you will push? Go to this particular state and this entry. Okay, so alpha is the symbol, you have a state, so given this thing you can find out the entry, right? If at all it is 1, so you can always find the entry, what happens. Okay, what was the alpha? Alpha was S, and what can be the other thing? Acha, there will always be a state in a stack, right? So in a stack, if you have something, according to that you will find the information from here, right? So A3, you will get this value 6, so you will keep this 6 in the top of the stack. Now the third thing is when this will be accepted. So if at all this action SA, you already understand this thing, that action SA is equal to ACC, then it is, we can say it is successful. Right? So given a string, what you can do, you will just keep on seeing the entry here, and then according to that you can do these following things, right? If at all it is a shift entry, you will shift A and I both. If at all a reduced entry, you will remove 2 times the number of symbols in the beta B side, and then you will replace it with alpha. Below alpha you will have a particular state number, so you will just find out the go-to of these combination, and you will push that value in the stack. If at all in the last, if you get this ACC, means then in that case it is successful. So that is very simple parsing algorithm. This parsing algorithm will work for all the parsers, all the LR parsers, and this is how you are going to work for construction of parsing table, right? So these are few things we have learned today: parsing table construction and LR parsing algorithm. Accordingly, now you can use some string for a given grammar, and then you can find whether it is accepted or not. Now your assignment will be to create this parsing table and to use some string to validate whether it is working correctly or not for a particular grammar, right? Okay, so for now I think it is okay. Thank you.